Okay, so part 2 of this video, we're going to just start diving into a lot more examples of different ways you can see it. So the next example, if you notice, I'm on the next page. So this one was the before page. Now it's the very next page. So next example, we're going to head and let's do 2s plus 5 is greater than or equal to 49. Okay, so 2s plus 5 is greater than or equal to 49. All right, so again, first step is to solve the problem as is an equation sign. All right, as if it's an equation. Don't worry about the symbol just yet. So solve for variable. Okay, so we're trying to get this variable s by itself. And the first thing that we're going to do is look at your plus or minus with your numbers. All right, so we have a positive 5 or an addition of 5. The opposite is a subtraction or a negative 5 to both sides of the inequality. Okay, we take our 2s and we bring it down because we're not using that yet. We're not doing anything with it yet. Positive 5, negative 5 is our zero pair. We still bring down our inequality. And then 49 minus 5 is 44. Okay. The next piece, we have 2 times s, 2s. So to multiplication, the opposite is division. 2 divided by 2 becomes your 1s, your inequality here. And then we divide by 2. 44 divided by 2. 2 goes into 4 2 times. So s should be greater than or equal to 22. All right, we want to make sure and check. Or you know what, instead of checking, let's go ahead and just put this on the number line. All right, so underneath, let's go ahead and put our number line down. Okay, and since my number is all the way big at 22, I'm not going to put 0 and then count all the way to 22. I'm just going to go ahead and put 22 in the middle, and then I can put 23, 24, then 21, so on and so forth. That way, I just am putting a basic piece of the number line. The arrows mean the numbers continue, right? So I don't need to put all numbers up all the way up to 22. All right, so when we plot this point, if you remember from the front page, and I'm going to flip over real quick, when we have the greater than symbol or equal to, we put a closed circle on the number line because it's saying that this number can be included as a value of the variable. Okay, so s can equal 22. So at 22, we're going to put a closed circle, but s can also be greater than 22. And so this greater than gives us an arrow that goes to the right. So any value including 22 on up can be a value, can make this a true statement or be a value of s. So if I plug in 22 for s, and I'm going to do that over here, 2 times 22 plus the 5 should be greater than or equal to 49. So 22 times 2 is 44 plus 5. And 44 plus 5 is 49, which is greater than or equal to 49. The equal to makes this a true statement. Let's go ahead and plug in 24 since it's included in the greater than portion of it. So down here we have 2 times 24 plus 5 is greater than or equal to 49. So 2 times 24 is 48 plus 5. 48 plus 5 is 53, greater than or equal to 49. Is 53 greater than 49? Yes, so that is good to go. So that's what I usually do. Is 49 greater than 49? No, but 49 is equal to 49, and that's what makes this a true statement, because we have both there, greater than or equal to. And so both these statements are true. Okay? If you wanted to check the other side that your arrow is not pointing to, then let's look. Let's plug in 21. Okay? So if we have 2 times your 21 plus 5. We need that to be greater than or equal to 49. 2 times 21 is 42 plus 5. And 42 plus 5 is 47. So you can ask yourself, is 47 greater than 49? No. Is 47 equal to 49? No. So this one is not a true statement. Okay, that 21 cannot be a value of S because we need S to be greater than or equal to the 49. All right, so the next example we want to look at is A divided by -8 plus 15 is greater than 23. So A divided by -8 plus 15 is greater than 23. Again, remember, you want to solve these as you were solving a normal equation for A, all right? Look for the variable. We're trying to get the variable by itself. So in doing so, we are going to subtract 15 first from both sides. We don't do anything with the A divided by -8 yet, so we just bring that down. This is 0, 0 pair with the positives and negatives equaling each other. Greater than 23 minus 15 is 8. Okay? Now, I'm going to throw something else at you. We have a division here. So the opposite of division is your multiplication. We need to multiply by -8 on both sides. But here's the kicker. Okay? Something else to remember. And this is important. When you multiply by a negative number, you must reverse the inequality. So this inequality now switches over. So you started off with a greater than symbol. You're going to reverse it to a less than symbol. It is because you are multiplying by the negative. Okay? So an 8 divided by 8 does equal 1. So you're left over with A by itself. Now, 8 times 8 is 64. And a positive times a negative equals a negative. Very good. All right. Plotting this on a number line is not changing. When you do this, we still have a what type of circle for the less than symbol? Open circle. I have a -64, so I'm going to put some lines in here. And we're going to go, I always put my number in the middle of my line. So -64 to the right would be getting closer to 0. So this is -63, -62. To the left would be getting further away from 0, -65, -66. Okay, we put our open circle at negative 64. And let's think about this. It says A is less than negative 64. If you're going to the right, your numbers get bigger. Okay, the closer you get to 0, your number gets bigger. If that's hard to believe, you don't want to owe money to people, so the more you owe, the further away you get from 0, and that's not what you want. The less you owe, the closer you get to 0, and that's even better, especially whenever you get above the 0 mark. All right, so it's the best way I can explain it with money. So since we are less than that, you go to the left. And anytime you say less, which starts with an L, you go to the left. The other thing I want to point out is, I don't know if you've noticed, but since the variable is on the left-hand side, okay, the inequality has pointed the same direction as our examples. The variable on the left-hand side, and it's pointing the same direction. That only works when it's on the left-hand side. If the variable is on the right-hand side, which is the next example that I will do, it does not work in the same manner. It is about how it is said at that point, or you would flip it around so that you could use it as a guide. All right, but we're going to do a whole other example with this negative and knowing what to do here. So let's go ahead. I don't have enough room on this page. We're going to move one more page over. And we're going to call this example. Okay, and so let's do negative 3t plus 9 is greater than or equal to negative 21. Okay, oops, sorry. Didn't realize I'd done that. So negative 3t plus 9 is greater than or equal to negative 21. So let's go ahead and start solving for this. We have a positive 9 here, so we subtract 9 on both sides. We didn't do anything with our negative 3t. Our greater than or equal to sign is still there. And a negative, look, we have two negatives that we are putting together. So we are adding two negatives. This is our integer rules for adding negatives. Same sign we add and keep. So 21 plus 9 is 30, and we keep the sign negative. Okay, so now that we keep the sign negative, the next step is our negative 3t. This is negative 3 times t, okay? And before, when we said when you multiply by a negative number, you must reverse the inequality because we had a division, so we had to multiply by a negative number on both sides. Here, you're going to have to divide by a negative number. The same rule applies. So, again, when you divide by a negative number, the inequality reverses. Okay, so since I am dividing by the negative 3 on both sides to get t by itself, the inequality then reverses. Instead of having the greater than or equal to, now I have the less than or equal to. And then negative 30, or look, let's just hold up. Let's do our division. 30 divided by 3 is 10, and a negative divided by a negative equals a positive. If you didn't remember, you can use your tic-tac-toe for a negative divided by a negative equals a positive. All right? Last thing to do is to go ahead and put this on a number line. and we have 10 as our number. So we want, let's say 11, 12, 13, 9, 8, 7. So it is saying t is less than or equal to 10. So at 10, with the less than or equal to tells me to put a closed circle because it can't include that number. Okay, the equal to part can't include it. And t is less than 10. So we go to the left. Okay, be prepared to do more equations or inequalities in class time. We'll discuss, especially using the negatives, a lot further in that. It's very important that we understand whenever doing negatives that we reverse the inequality, and that is only with multiplying and dividing. See you in class tomorrow.